Hello, grade 10s. Welcome to our next lesson on number patterns. So we're going to start off by just going over the corrections from the homework that I gave from 3.1. Okay, so we start with number A14. So when you look at this number pattern, we're going to go through these answers quite quickly because hopefully by now you've started to pick up on the patterns a bit easier. So you can see that all you're doing here to find the common difference is that you are just adding 3 over 4. Okay, you can again convert this 1 into a fraction where 4 is the base, which will be 4 over 4. Then it should be quite easy to see this. But you can also just do it on your calculator. It's not necessary to do either one. Okay, so then finding C, which I'll do first, I can see is going to be a quarter minus 3 over 4, which is just going to be negative a half. Okay, so your final answer then for Tn is going to be 3 over 4n minus 1 over 2. You can also say 3n over 4 is also fine, but this one on the left is the preferred way of doing it, just in this case. So T100 will be 3 over 4 times 100 minus a half, which is just going to be 74 and a half. Okay, if you don't want to leave it as a mixed number, you can also leave it as 149 over 2. Okay, so there's your answer for T100. Okay, moving on to 16. So again, when I look at this, I can see the common difference is quite easy to spot. I'm just adding 6. So that's the common difference. And then the C value I'm going to find by saying, well, C is equal to T1 minus D, which is negative 13 minus 6, which is going to be negative 19. So then Tn is equal to 6n minus 19. So if you want T100, you'll have 6 times 100 minus 19, which is 600 minus 19, which is 581. Okay, then the last one I gave was 17. So 17, again, it's quite easy to notice you are minusing, and to get from 1 to minus 9, you have to minus 10. Okay, so you can already see that C will be T1 minus D, which is 1 minus negative 10. Okay, which is going to be positive 11. So just be careful of the signs here. That is the biggest concern with something like this, again, is just the signs. So Tn is going to be equal to negative 10n plus 11. So if you want T100, you will say negative 10 times 100 plus 11, which is just negative 989. Okay, so moving on, I gave you D to do as well. So I'll do D here. So D specifically asked you, it said that the general formula Tn is equal to 9n minus 4 is the nth term of that linear sequence. So the first question said that you had to determine the first 4 terms of the pattern. So basically they want T1, T2, T3, and T4. Okay, so you'll say 9 times 1 minus 4, 9 times 2 minus 4, 9 times 3 minus 4, and 9 times 4 minus 4. Okay, you can do this in any format. Okay, this is just the way that I would prefer doing it. So, but again, like I said, it's really up to you. So you would have 5 for your first term, then 9 times 2 is 18, minus 4 is 14. Okay, 9 times 3 is 27, minus 4 is 23. And then 9 times 4 is 36, minus 4 is 32. So you write it out, 5, 14, 23, 32. Okay, then the second question says that you must, which term is equal to 986? So it says which term. So that means they want to know what n is if Tn is equal to 986. Okay, so just make some more space. That means that we can say, well, Tn is equal to 9n minus 4, but we know that Tn is 986. And we're trying to solve for n. So we add 4 on both sides, and we divide by 9. So we'll get the final answer to be 110. So therefore, T110 is going to be 986. Okay, so then I ask you to do I. Okay, so I gave you a sequence where it said 2x plus 2 is the first term, x plus 9 is the second term, and x plus 6 is the third term, and it goes all the way, and they give you the final term in the sequence, which is negative 101. Okay, so they told you that's the last term. Okay, so the first question, it just simply asks you to find the value of x. Okay, like we did in the previous examples, all we're going to do is we're just going to use the common difference. So we're going to say, well, T2 minus T1 is the same as T3 minus T2. They already told you it's linear, so we can make the statement. So we're going to have T2 minus T1, which is equal to T3 minus T2. Don't forget your brackets. So T2 is x plus 9, T1 is 2x plus 2, T3 is x plus 6, T2 is x plus 9. So then we'll just continue to simplify this out. So you will have x plus 9 minus 2x minus 2 is equal to x plus 6 minus x minus 9. Okay, if you simplify, you'll get negative x plus 7 is equal to negative 3. So therefore, x is going to be positive 10. Okay, just basic solving for x. Okay, that was the first question. Okay, the second question said to you, calculate the number of terms in this sequence. Okay, so we need to find out what the number of terms are. So obviously, in order to find the total number of terms, we then are basically saying, well, this is T1, this is T2, this is T3, and it's going to end at this Tn. So we want n, isn't it? Because we don't know exactly on which term number it ends. But in order to find n, we need the actual value for Tn. Okay, so you would have said that Tn is going to be equal to, now this was something that you had to figure out by first substituting x in the place that it is in the sequence. So your terms, if you did that, would have been 22, 19, 16, up until 101, negative 101. Okay, so that means that if you see the common difference here is minus 3. So Tn is minus 3n, and the C value, which is T1 minus D, is going to be 22 minus 3, which is just minus negative 3, sorry, which is going to be 25. So it'll be plus 25. Okay, so they basically want you to find what n is if they told you that, well, Tn, the last term, is negative 101. So negative 101 is equal to negative 3n plus 25. So negative 3n is going to be equal to negative 126, because all we do is we just take this and we minus it. So that means that n is going to be positive 42. Remember, it has to be a whole number. So therefore, the 42nd term is going to be negative 101. Okay, so therefore you can conclude and say 42 terms in the sequence. Okay, not too difficult. You just have to be able to interpret what the question is actually trying to ask you. Okay, then number 3. Number 3 says, what is the value of the 12th even valued term in the sequence? So let's have a look and see. This one is again going to be a bit tricky, but let's take our sequence as it is, 22, 19, 16, and let's just write a few of the terms out. Okay, because remember, they're asking you about the terms. So let's see, we have 22, 19, 16, and then keep going so that you at least have 3 even terms. Okay, so remember the difference is minusing 3, so it'll be 13, 10, 7, 4. So if we want, and then it continues. So if we want to know what the even terms are, we're going to pull them out. So there's 22, 16, 10, 4, and so it continues. So we're going to make a new number pattern using the even terms. So we have 22, 16, 10, 4, and so it continues. So now it says to us that we need to figure out what is the 12th even value term. So basically they want the 12th term in this even terms. So they want you to find T12. So firstly we need Tn. So let's see. The common difference here is that I'm subtracting 4. So I'll have negative 4n plus c. So the c value 22 is equal to negative 4 times 1 plus c. So c is just going to be positive 28. Okay, so you're just trying to find Tn. So Tn is equal to negative 4n plus 28. Now if they want T12, we'll say, well, T12 is equal to negative 4 times 12 plus 28, which is just going to be negative 44. I think I made a mistake. No, let me double check. So it will be 22 plus 4 is 26. Sorry, y'all. Okay, so it will be minus 4n plus 26. So we have minus 4 times 12 plus 26, which is going to be negative 22. Okay, so if we look at the value that was given to us. So the next question is the 12 value term in the sequence. However, we have to take note of the fact that now we're trying to find the odd value term. Okay, so if we look at the odd value term, we'll see that the sequence again, now I'm going to pull out odd values. So I will have 19, 13, 7, and so it continues. So my new pattern is going to be, this is number 4, will be 19, 13, 7, and so on. So again, we're trying to find T12, so we want the Tn here. We can see that the difference is that I'm just subtracting 6. So it will be negative 6n. The C value, I can state, well, will be T1 minus D, which is 19 minus negative 6, which is going to be 25. So positive 25. So then T12 is going to be negative 6 times 12 plus 25, which is just going to be negative 47. Okay, and remember, I guess kind of as a way to just check yourself is that remember that they're asking for odd numbers, so and even numbers. So you must make sure that your actual answer is an odd or even number depending on what they asked. Okay, hopefully I'll have enough space to finish these, do J. Let me just clean it up a little bit. Okay, otherwise I can always just add an additional page, which I'm probably going to need to. So let me just add the additional page. And then we can do J on the next page. Okay, so J says write down the constant difference in terms of x. Okay, so if they want the constant difference in terms of x, it means that we are not trying to solve for x. We're just trying to find what the constant difference is in terms of x. So what that means is we're trying to find the constant difference, the common difference, which we can either say is T2 minus T1, or we could say that the difference is T3 minus T2. So you can use this one or this one to find the common difference in terms of x. You should get the same answer. Okay, so let's have a look. If we take the first one, T2 minus T1, we would see that the common difference in terms of x would be 3x minus 2 minus x plus 1. And then all we do is we just simplify it so that we have a expression for d in terms of x. So we would say, well, d is equal to 3x minus 2 minus x minus 1. And then we'll just simplify it to say, well, this will be 3x minus x is 2x, and minus 2 minus 1 is minus 3. Okay, so this is the common difference in terms of x. Okay, I can show you what would have happened if you used T3 minus T2, which you could have also done. You would have said, well, then the difference is T3 is 5x minus 5 minus T2, which is 3x minus 2. So you have 5x minus 5 minus 3x plus 2. So 5x minus 3x is just going to be 2x, and minus 5 plus 2 is minus 3. Okay, so notice you get the exact same answer. Okay, that is the answer to number 1. Then number 2 says find the nth term in terms of x. Okay, so they want the nth term. So don't get overwhelmed. We start with the basics. We know that Tn is equal to dn plus c. Okay, so what we're trying to then find is we already know what the common difference is, right? The common difference is 2x minus 3. So we can find c now using that formula T1 minus d, isn't it? Because I can say, well, I know the first term in terms of x is going to be x plus 1. So I'll say x plus 1 minus the difference, which is 2x minus 3. So then let's simplify that. X plus 1 minus 2x plus 3. So x minus 2x is just going to be negative x, and plus 1 plus 3 is plus 4. So I have d and I have c. So I can put that now into my equation. So I'll say, well, therefore, Tn will be equal to 2x minus 3n plus negative x plus 4. Okay, and you can just leave it like that. You don't have to go further than this. Okay, so this is kind of like a level 4 kind of question. It's not really a very common question. It's just to kind of get you to be exposed to just a different way of asking the question. Okay, but it's not necessarily that if you're struggling with this, it's like you don't understand. It's just a way to stretch your thinking a bit. Okay, then the third question says, if the value of the 12th term is 106, then find the value of x. So what we're trying to do is, we're trying to use what was found here in the next question. So I know that we've been finding x using the common difference rule, but now it's just, again, like I said, to expose your thinking. So they want you to find T12. Well, they want you to use T12 to figure out what x is. So that means that you have 2x minus 3 times 2 minus plus negative x plus 4. But now you know that T12, they just told you, is 106. Okay, so you can simplify this. So it'll be 12 times 2x, which is 24x. 12 times 3 is negative 36, so I'm distributing. Minus x plus 4. Okay, you distribute the positive in. Then you're going to simplify, so you'll get 106 is equal to 23x. Minus 36 plus 4 is minus 32. Divide both sides by, add 32 to both sides. You would get 138 is equal to 23x. And then if you divide both sides by 23, you will get x to be equal to 6. Okay, so I understand that this was probably a little bit difficult. That's why you would have noticed that it has a star next to it. And remember, the stars are the level 4 kind of very challenging questions where you won't often see them in cycles or anything like that, but you know, they can come out at any point. It doesn't really count a lot, and it's just to expose you to a different type of thinking. Okay, so after that, you can rule off. Okay, then you can write the date, which will be the 12th of May, and the heading is applications with number patterns. Okay, so applications with number patterns is basically the level 3s and the level 4s of these number patterns. So this is now where we take everything that we've learned and we start applying it to questions that use application bases. So that would be like objects that form patterns, or we're going to look at a different way of looking at the number patterns, maybe some number patterns that are not considered linear, and so on. So that's why they kind of are like the level 3, the level 4, the more difficult questions. So I recommend that you pause the video here, take down the whole question. So we have example 1, which says consider the pattern with blue and pink squares. The first 4 patterns are shown. Okay, then you can draw all 4 patterns. Okay, you don't have to use the same colors as I've used, but just make sure that whatever you use, they match. So whatever you use for the pink, it must match for the pink, and whatever you use for the blue, it must match for the blue. Okay, then there are your questions. So again, like I said, just pause the video here on this page, and then you can write down all the questions, and then we'll answer them together. Okay, so let's take a look. So what I'm going to do is I'm going to answer these questions underneath this example. So we'll have question 1. Question 1 says, how many pink squares are there in the patterns 1 to pattern 5? Okay, so we can see in the first one, we're just counting. We have 1 in the first one, 3 in the second one, 5 in the third one, 7 in the fourth one. So let's start with the ones that were given, and then we'll just predict what the fifth one is going to be. Okay, so we can see that the first one was 1, 3, 5, 7, and then I'm sure when you look at this pattern, you can tell that the next one is going to have 9. Okay, so the second question now says, determine the number of pink squares in the nth pattern. Okay, so we already have our term here. So all we're going to do is we're going to say, well, Tn is equal to Dn plus C. I'm sure you can tell that the difference is I'm just adding 2. So that means that Tn is equal to 2n, and then I can calculate C on the side. T1 minus D, which is 1 minus 2, which is minus 1. So the final Tn is just going to be 2n minus 1. Okay, easy enough. Then the next one says, how many pink squares are there in pattern 20 and pattern 100? So they just want you to then tell me what is T they asked for, T20 and T100. Okay, so we can see that with T20 we just substitute in, so it'll be 2 times 20 minus 1, which is going to be 39. And then we have 2 times 100 minus 1, which is 199. Okay, so that's how many pink squares are in T20 and in T100. Okay, now let's have a look at the next one. The next one is a little bit tricky. It says, consider the sums of the pink squares. So what they've done is they've made a new pattern where they've taken the first pattern, then they've taken pattern 1 plus pattern 2, then they've taken pattern 1 plus pattern 2 plus pattern 3, and they've taken pattern 1 plus 2 plus 3 plus 4 all together to get 16. So then it says, find the number of pink squares from pattern 1 to 7 inclusive. So that means what is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. They want to know how many. So let's first start by writing out the sequence that was given in yellow. So I have 1, 4, 9, and 16. So if we have a look at this, right, we can tell that I'm just adding terms from this sequence here. So I can see then that I'm going to have 1 plus 3. So the fifth, if I'm adding the fifth pattern, I'm going to have 1 plus 3 plus 5 plus 7 plus 9, which you should see is going to be 25. Okay, and then we can continue like that. So we're just going to use a trial and error for now. So we'll see that the sixth one, we're quite close, so we can just continue. 1 plus 3 plus 5 plus 7 plus 9 plus 11, which is going to then be 36. So then the seventh one inclusive is just going to be 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13, which is 49. Okay, so there's 49 in pattern 1 to 7 inclusive. Then it says calculate the sum of 1 plus 3 plus 5 all the way until plus 199, which is the total number of pink squares from the pattern 1 to 100. So now we encounter a bit of a problem. Okay, because doing 7 terms was fine, but we can't go count in twos like this until we get to 100 terms. Okay, that's just going to take us way too long. So again, we need to figure out a TN, or we need to figure out a rule. So if you would have noticed, so I can repeat the pattern again, and I'll add what I found. I have 1, 4, 9, 16, 25, 36, 49. So if you can remember from last year, there were some special number patterns that we were looking at where there's not necessarily a general rule in the sense that it's linear. In this case, we could tell it's definitely not going to be linear, because here you're adding 3, and then all of a sudden you're adding 5. And then again you're adding 7. So you see that there's no common difference here, which means that this is considered to be a special number pattern. Okay, so let's have a look and let's think about it. So one thing that hopefully you would have noticed is that all of these numbers are square numbers, which means that they are all perfect squares. So if you notice, this is the same as 1 squared, and this is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and 7 squared. So it's basically each term number squared. So if we wanted to basically use a general rule for this, then we'll notice, oh, but we could find any number in the term by just saying Tn is equal to n squared. So they said they want to know all the way up until 199, which is technically the total number of squares from pattern 1 to pattern 100. So that means that all we're doing is we're just going to take 100 squared, which is going to be equal to 10,000. So there are 10,000 pink squares from pattern 1 to pattern 100 inclusive, meaning that if you add all of the squares together, you'll get 10,000. Okay, so this is just a unique number pattern that we find forms in this. Remember, like I said, it's application based now. So now we start exposing ourselves to the special kinds of number patterns. Okay, so let's have a look at the next one. It says, how many squares, pink and blue, are there in each pattern from 1 to 5. So now let's figure out, they basically want to know how many total squares there are. So this one now, we're not necessarily distinguishing between the colors. So we see here there's 2, then the second one is 2, 3, 4, 5, 6, and the third one will be 6, 7, 8, 9, 10, 11, 12, and so we'll write that out from 1 to 5. So again, we'll have to predict the fifth one. Okay, so the first one we said at 2, then 6, then 12, then 20 will be at 4. So then if we have a look, you'd predict what the next one would be. So hopefully if you notice, you'll see, okay, here I'm adding 4. Here I add 6. Here I'm adding 8. So hopefully you should be able to pick up that you're going to add 10 in order to get the fifth term, which is going to be 30. Okay, so all the question just asked you is how many squares are there in each design. So you just had to basically give all the sequence from 1 to 5. Okay, then the last one says determine the number of squares there are in the nth pattern. Okay, so this one I can see is going to be kind of tricky. We don't really cover this number pattern in detail right now, but we do cover it a lot in grade 11. Okay, so we can see that, of course, first of all, the pattern is nonlinear. So Tn is equal to Dn plus C is not going to work. Okay, and the reason why is because this pattern is non-linear. Okay, so the methods that we used is no longer applicable. So now we need to basically investigate a different type of method that will work for this type of sequence. Okay, so a useful method is to work with the number pattern in the investigation and to develop your number pattern from there. So let's have a look and see. We start with 2, 6, 12, 20, 30. So the difference between these two is going to be 4. This one is 6, this one is 8, this one is 10. So if I think about that, I have T1, T2, T3, T4, T5. So if you say T1, we could always say 2 times 1, which is 2, but then 1 would obviously come from the 1 here. But if I say T2 and I use the same principle, it doesn't work. Okay, I get 4. So I need to then figure out a different method, okay, because that didn't work. So I know that T1 is 2, T2 is 6, 12, and 20. Okay, we're not really going to look at 5 because we don't really need it. Okay, so again, like I said, this is purely level 4 questions. So this is not necessarily something that you are going to be tested on a lot. Okay, it's a very, very, very small type of number pattern that is only really studied properly in grade 11. Okay, but notice that if I said that this is the same as technically 1 plus 1, And let's for a moment think, okay, well, what if this is n plus n? But we just said that 2 plus 2 would not equal to 6. However, I noticed that if I took 2 squared plus 2, I would get 6. So now I basically use the same principle to say, well, if I had 3 squared plus 3, I would get 12. And what about if I had 4 squared plus 4, I would get 20. So the general pattern here would be Tn is equal to n squared plus n. But again, like I said, this is a very exceptional circumstance. Okay, so this is only really going to be done in grade 11. Okay, so don't worry too much about it this year. Okay, again, like I said, it's just trying to expose you to a different way of looking at the number patterns. Okay, so I hope that this lesson wasn't too intimidating. I hope that you were able to take something from it. Okay, and then your homework will be from exercise 3.2 on page 69. Okay, I want you to do number A, number B, number C, but I only want you to do number 1 and number 3. And that's it. Okay, so I've just given you exercises from this particular exercise that you could potentially be asked. So I don't really recommend doing anything else because it's not something that I'm looking at testing right now. But definitely A, B, C, 1 and 3 is something that I would put inside the exam or cycle or something like that. Okay, so just make sure that you go over those questions. Okay, otherwise, then I hope that the lesson was good. I hope that you have a good week. Okay, one more week and I'll be back. Okay, so please make sure that you are working, and yeah, I'll see you on the next one.